We are a collaborative research program, applied research, and we are taking the risk to put public money on these projects to get innovation that is useful for European industry competitiveness. This is our only reason for doing research. We have difficulties in this area because the market is small, because the investment from industry is relatively low, and this is why we are supporting this activity. There are many factors that hinder or delay the execution. We have knowledge gaps in biochemical pathways, for example, when we take a measurement at the molecular level, or technology gaps. I will give you some examples. Reliability, liability issues, cost and affordability, and other issues like ethics. So our goal in this MNBS initiative is to start from the cluster and to expand to a broader EU sustainable and competitive initiative worldwide to create a body or a forum or a joint venture to increase the R&D investment, facilitate the innovation and uptake, facilitate sustainable use of resources, identifying also strategic drivers, and leveraging effects, and contribute, as I said, to a strong European industrial base. So let me come to the last part of the presentation very shortly, what we're doing in Framework Program 7. This is the part of the collaborative part of the cooperation, I would say. So you have to apply proposals with different partners. You cannot be alone to develop this. And this is really matching with the need for interdisciplinarity and complementarity in the consortium. And in the information technology, it is 9 billion euros to be spent these 7 years, 2006, 2013. What we expect, what people expect from microsystems is to achieve substantial improvement on various aspects of smart system integration, to provide innovative concepts in order to increase productivity, to contribute to increase market share for European companies. These are our upper goals. We have opened a call in FP7, call 2, where these activities of next generation smart systems and micro nano bio ICT convergence have been opened. It was a call of 83 million euros. And in this specific area of nano bio ICT convergence, we were looking for applications, for technology that could enable applications like environment, agriculture, food quality, safety, and biomedical and lifestyle also. And this is the result of the call 2 in microsystems. So projects involving materials, sensors, actuators, 2 subgroups dealing with MEMS and NEMS and micro-nano convergence. 33.6 million out of these 83 have been given to this area. And also some other supporting actions in manufacturing. And you have here the statistics. Out of 70 MNBS proposals, 9 were retained. This call was very difficult. 1 out of 8 proposals were successful. New projects that were selected in this call will join this group on micro-nano biotechnologies like PITIA, Lab-on-Foil, Microfluid Ultra, also in the area of microrobotics and integrated microsystems, like for abdominal surgery, sensors and transducers for in vivo detection ultrasponder, mini-surge, nanoma, and also multi-channel electrode system time for induction of cessation and treatment of phantom limb pain in amputees. So the major challenges here are very variable, very diverse. We have difficulties to start and to push the different directions because the researchers have to make a decision on which operation scale to go, either for in vitro or for in vivo. Which aspects to prevail? Autonomous, external power, decision capable, open loop, closed loop. Also you have the needs for diverse technological platforms, for example, sensing or actuation technology. Would it be an assay technology to go or for emotion detection or for a drug delivery? So there are multiple platforms, multiple technologies, and it's not always easy to select the best one for the specific application. What will be the main orientation for future R&D in this area? In the next work program 2009-2010 that we are preparing at this moment and will be finalized around September. We continue to further integration and interface in multi-core technologies, micro, nanoelectronics, microfluidics, chemistry, bioengineering, magnetic, etc. And also to have some application-specific microsystems in biomedicine, in food quality, environment, automotive, etc. This is the big idea. There are some people who say there is no need to do research anymore because technology is there and there is just need to validate and to prepare the regulatory framework. I personally don't agree. There are huge challenges and problems to solve from the technical point of view, starting with materials, going to energy generation, storage, so power efficiency, transportation of sample and storage of regions, how to make flexible and robust electronics, interconnections, packaging and assembling, miniaturization of long-life power, battery. It is extremely important for a neurosurgeon to know if the implant will be put in the brain for 5 years or for 10 years. And this has consequences in the whole value chain of the product. Electronics, as I said, miniaturization, energy scavenging, enhanced functionality, wireless technology. Paolo made a lot of, let's say, underlined very much the wireless aspect of these devices, packaging techniques, and the key challenges are to close the loop. So this is my last slide. Finally, technology is not everything, for sure. I agree with you. And we need to think about technology in terms of integration, manufacturing, and industrialization. And there we see that what is important is to be able to commercialize MST with very low cost of fabrication. These products need to be really low cost. Approaches to improve different aspects, new manufacturing approaches, tools for manipulation of biomolecules, there is not enough system available, improve microfluidics, which emerge as a key enabling technology. And all these aspects, I just gave you examples, are addressed by this group. So I don't know if I convinced you about how important it is to make research in this area, but I'm sure that the speakers that will follow me will give you the best demonstration of this need. Thank you very much.